All right, guys. I'm not sure if we covered this in class together or not, so I'm just going to put this video up there. I don't know what we're going to cover tomorrow, being Thursday. All right, so today we're going to talk about compound inequalities. This is already in your notes, so go ahead and take those out, and we're going to fill these notes out together. Compound inequalities, all it is two inequalities. Two inequalities or more, joined together with and or. Okay? All right, so go ahead and take that down. Or inequalities have a tendency to graph outward. So they're going to go apart from each other. To graph apart. And here's an example. So we've already done the multi-step inequalities, I guess when we were together on Thursday. So here's my example. This is an or statement. This is type 1. We're going to be doing two types. So or statement, all it is I'm going to graph them. Here's negative 2. It says x is less than or equal to negative 2. So there I go. I've graphed that before. But now I have another one. It says or x is greater than 3. So that means that my solution can be 2. I can have, my value can be negative 7, and my value can be positive 7. I can have two separate solutions that fit whatever type of problem this is. We already know interval notation for 1, and so this one would be negative infinity, oh, that's ugly, negative infinity to negative 2 blocked off. Now, because it's an or statement, you must write the word or parentheses 3 to infinity. And of course, infinity always has the parentheses on both sides. Now, we're doing three types of notation here. We need a written notation, which is this. We need a graph, and we need the interval notation. So three pieces on the homework that I'm going to be checking for. Written, graph, and interval. So my written form is actually written correctly. Okay, I can write it like this. And what I mean by that is we go from least to greatest. Since they're two separate lines, I start with the least, separated by the word or, and then my greatest. So that actually is a good example of a written one. All right, so now let's talk about what this looks like when we graph. And I'm only going to do one of these. Actually, I'll do two. If I can get this to erase. All right, here we go. So let's take a look at number 2. My rules are still the same as they have been. I solve for x. I'm dividing by a negative 3, and you know when you divide by a negative, my inequality sign slips, so it's going to be x is greater than or equal to 3, or I'm going to subtract 5, additive inverse, x is less than 1. Okay? Now, remember my written form goes least to greatest. So 1 is here, so I'm going to go x is less than 1, or x is greater than or equal to 3. Written notation box. I'm going to graph it. Here's 1. Open circle, shade to the left. X is greater than or equal to 3. Close circle, shade to the right. So my interval notation is going to be negative infinity, comma, 1, parenthesis. I must write the word or 3 blocked off to infinity. Okay? All right, so that's number 2. Go ahead and try number 4 on your own. And if you need to pause it to go ahead and work through it, pause the video and work through it. That's not working. Okay, so number 4, I'm going to do the additive inverse, add 14, 7x is greater than or equal to 14, divide by 7, and x is greater than 2. Additive inverse, subtract 5, 4x is less than or equal to negative 8. Oh, this is equal to as well. Divide by 4, and x is less than or equal to negative 2. All right? So my written form's got to be least to greatest, so negative 2 is going to come first. So x is less than or equal to negative 2, or x is greater than or equal to 2, and I box that. When I graph it, close circle on negative 2, shade to the left. Close circle on 2, shade to the right. There's my graph. My interval notation, my graph starts at negative infinity. It goes to negative 2, blocked off. Or I must have that word, block it to infinity. All right? So hopefully Ms. Patterson can answer any questions that you have before we go on to our other kind of compound inequality, which is going to be the and statements. So type 2 is and. So and inequalities have a tendency to graph together. They're going to come up and they're going to meet. So these graph together. And here's what that looks like. So if I solve my inequality and I get x is greater than or equal to 6 and x is less than or equal to -1. So it's closed circle on -6, x is greater than, so I go this way. This one says x is less than or equal to 1, so it's closed circle on 1 and I shade this way. So now all the solution to this inequality is all within this certain part, okay? So -6 can be an answer, -5, -4, -1, -2, 1, and 0, and all those fraction parts in between. All right, so that's my graph. My interval notation is pretty easy. It's blocked at -6, and it blocks at 1. Okay, so it's still that, I still read left to right, and so that's my interval notation. Your written notation is going to be different. So I want you to highlight that this part is different. The easiest way for me to do the written notation is to do it above the graph, because this is, I tell myself, okay, I'm dealing with one variable x, and I'm going to put it in the middle. Where did it start? It started at -6. Where did it end? It ended at 1. So now it's going to be x is less than or equal to 1, and my inequalities are going to go the same direction. So notice my arrows are always going to go in the same direction. They're never going to be different. So what this says is x is less than or equal to 1, but if I read it backwards, x is going to be greater than or equal to -6. So that is my written form, okay? All right. So on here, we would just rewrite it. So because solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form, which is that form that I just showed you. So if you have x is greater than or equal to -6 and x is less than or equal to 1, it's going to look like this. Least to greatest, x in the middle, and bam, there it is, okay? All right, so let's try, how do we solve these guys? All right, let's take a look at how we solve them. So you have two, I can expand that a little bit. You have a left side and a right side. So now what I'm going to do is I need to get x in the middle. X is going to stay on the middle. So I need to get rid of this 4. So I do it by additive inverse, subtract 4. Well, watch where I'm going to subtract 4. I'm going to subtract it from the left side, and I'm going to subtract it from the right side. And now I'm going to read my statement. 2 minus 4 is -2, is less than or equal to x, which is less than 5. And my written statement is given to me. Least to greatest, so I can box that. And now how do I graph it? -2, close circle on -2, open circle on 5. I always read this statement first because my arrow goes in this direction. X is less than 5, and when I read it backwards, x is greater than -2. So that meets up in the middle. An interval notation is -2 and 5. This may be a good point to pause the video and answer any questions that you may have over it. And then join me back up and we'll do some more examples together. All right, so hopefully you got your questions answered. So let's do number 7 together. So remember, I'm still going to get rid of that -13, so I'm going to add 13 to both sides. And then I read top down just what I've been doing all year. So -14 is less than 7x, which is less than 21. I still want to get x by itself, so I'm going to divide by 7. I'm going to divide everything by 7. And I get -2 is less than x, which is less than 3. And look, it's already from least to greatest, so I'm doing okay. So I'm going to open circle on -2. I'm going to open circle on 3, and it's an and statement, so they connect together. Interval notation, parenthesis on -2, parenthesis on 3, and I'm done. Right, let's take a look at number 9. All right, so we'll We'll do 9 and 10 together. So if you want to pause it and then come back, and I can give you the answer. So give you a chance to work these on your own. All right, hopefully you had a chance to work them on your own. So we're going to subtract 1 on both sides. I get negative 2 is less than 2/3 x, which is less than or equal to 4. And now I'm still going to do the multiplicative inverse. So I'm going to multiply everything by 3/2. Multiply by 3/2. You should do these in your head. My 2's cancel out, so negative 1 times 3 is negative 3, is less than x, and then the 2 and 4 cancel out. 2 times 3 is 6. Least to greatest, so I'm in good position. So it's an open circle on negative 3, it's a closed circle on 6, and they join together. So interval notation, parenthesis on negative 3, block on 6, and there I am. Okay, so that hopefully you got that for number 9. Okay, let's take a look at number 10. We have to distribute first. So the steps don't change here. So I distribute first. So I get negative 2 is less than 2x minus 12, which is less than or equal to 4. And now I can do the additive inverse for 12. 12 and 12. And I get 10 is less than 2x, which is less than or equal to 16. Divide everything by 2. And I get 5 is less than x, which is less than or equal to 8. Least to greatest. It's already in written form, so I'm good to go. So I am going to open circle on 5, close circle on 8, and bring them together. Oh, you know what? Yeah, that's right. Okay, and so interval notation is 5 and blocked off at 8. All right, so there you go. Good luck, and I will see you in class next time.